Hello, pre-algebra. Welcome to lesson 8.2 in our geometry chapter. Today we will be reviewing definitions and properties of angles and using that information to help us find unknown quantities. So as a review, you have an angle. Two intersecting lines form an angle. The angle is here, angle X. We have side AB, and then we have side AC where they meet. It's called a vertex. So the name of this angle can be lots of different things. The vertex is always in the middle, so you can go BAC or the other way CAB, as long as the vertex is in the middle. It can also be called angle X, X being what we would be finding the measurement of that angle, so we could call it angle X, or we could simply call it by the vertex, angle A. Angles are measured in degrees. If an angle starts here and goes all the way around and forms a circle, it's 360 degrees. This would be an angle. Of course, if an angle is on a straight line, it's 180, and we have those instruments that I just very simply drew here called protractors that measure angle degrees, and we'll be getting into that in another lesson shortly. Okay, types of angles, very quickly. We have acute angles, which all the angles measure less than 90 degrees, such as the one illustrated. We have right angles where all angles measure 90 degrees. They're indicated by that little box and are perpendicular to one another. The sides are perpendicular. Obtuse angles are greater than 90 degrees but less than 180. So past the 90 degree mark but not quite down to the line. And it can go either way. Sometimes we see it this way because it's illustrated, but we don't see it the opposite way. So kind of get that in your mind too. And we have a reflex angle, which is larger than 180 degrees, but less than 360. So it goes past the line. So here would be the acute angle or the obtuse angle, whatever it may be, or the perpendicular lines forming right angles. And the area on the outside of that angle, like right in here, would be the reflex angle. So we have the inside angle and the reflex angle. And I have two illustrations there. As always, stop, pause, rewind as you need to get down your notes. And there are quite a few of them again today before we get into the triads. There are triads today, actually. So vocabulary, again, perpendicular is when two lines intersect at right angles, and then we would have four right angles in this case. So line AB, we would say, is perpendicular to line AB is perpendicular to line CD at F. And this is the symbol for perpendicular. Point F is also called the foot of the perpendicular because that's where it happens. Parallel lines are when two lines on the same plane do not intersect. Intersect means meet or cut into each other. So AB is parallel to CD because they would just continue on and never ever meet, whereas PQ and RS are non-parallel lines because eventually they would meet at point P. When we indicate lines that are parallel, we indicate them with little arrows. Sometimes if there are more than one set of parallel lines, the next set would be indicated with 2 arrows, and then the third set would be 3 if they are all on the same drawing. We start off with 1 and then we move on to the others if need be. Continuing. Here come our properties. If the sum of two angles is 90 degrees, the two angles are said to be complementary angles. So the big 90-degree angle here is CBA. The inside angles are complementary. They share a common side, in this case BD. However, they don't always have to be that tight. They can be separate from each other And if the measurements are totaling 90, then those two particular angles, even though they don't share a side, are said to be complementary. Continuing, number 2, if the sum of two angles is 180, the two angles are supplementary. So now we're just increasing the total degrees. So as you noticed, 180 degree angles form a straight line, ABC. The two inside angles total 180 and they are supplementary. Again, they do not have to share a common side. Like in this illustration, the angles share a common side of BD, but these two are actually separate angles, but they total 180. So those two angles are also said to be supplementary. Number 3, two angles that share a common side and a common vertex, but do not overlap, are called adjacent angles. So that only happens if they share the common side. We would call those adjacent angles because they're special. They're within one larger angle. Okay, continuing. Oops, there we go. Turn the page. Okay, continuing. Now here's our first major property. Okay, we had vocabulary and definitions, and now we're moving on to properties. So the first property we're going to look at is that the sum of adjacent angles on a straight line is 180. So we're talking about those supplementary angles. In this case, we have 3 angles that are supplementary because they all are on the same line and they form a straight line. So here's the property: adjacent angles on a straight line all total 180. So looking at try it on page 1, let's see, where are we? 188 it appears. It says in the diagram, and you'll need to look at that because I did not replicate it. In the diagram, XYZ is a straight line. Find the value of W. So you notice we have 140 in the middle and W degrees on either side. Now that means if it's W and W and not a different letter, that means those two angles that are each labeled W are equal. They are the same. So we just first of all line them up so we can prove it with the property. W degrees plus 140 degrees plus W degrees equals 180 because of this property. And this is how you write it. This is how you prove what you just did. We combine our W's. 2W plus 140 is 180. Now we even out the side by subtracting 140 from each side. 2W is 40. Now we work our way down to W by dividing by 2, and W equals 20 degrees. Okay, second property is that the sum of all angles at a point is 360. So if it's at a single point and there's angles going all the way around it, it makes a circle. If you just connect all the angles in, I didn't because I wanted you to see the separate angles here, but you know, if we just kind of extended that, it would make a circle, which is 360. The property for this is angles at a point. So they equal 360. So in Try It 2 on page 189, again, I did not replicate the drawing, you'll have to look, tells us to find the value of X in the diagram. So I'm simply gonna, I see that they go all the way around in the circle, so it's gonna be this property. So I just line them up and go 5x degrees plus x degrees plus 3x degrees plus 54 degrees is 360. That is 360 degrees is according to that rule, so that property, so you need to list it. I combine all my x's. 5, 1, and 4 is 9x plus 54 is 360. I subtract 54 from both sides. 9x equals 306. I divide through each side by 9. X is 34 degrees. Okay, so here we go. Our next property that we're going to be working with today, our final property with all those definitions, I think that probably is enough, says when two lines intersect, two straight lines intersect, the vertically opposite angles are equal. So vertically opposite means they're straight across from each other. So X and Y are vertically opposite, A and B are vertically opposite, and the property is vertically opposite angles. So therefore, angle A equals angle B and angle X equals angle Y because of that property. So moving on to try it on page 190. Again, look in your book so you can see the diagram. Tells us in the diagram EFG and HFK are straight lines. Find the measurement of angle X and the measurement of angle Y. So the measurement of angle X is going to equal the vertically opposite angle that it is, and they just decided to list what that angle is, which is angle EFH. F is the vertex, so that comes in the middle. You could have said HFE too, and that would have been fine, as long as F is in the middle. So we have to indicate that those two labeled angles are vertically opposite angles, and since EFH is 38 degrees, angle X is going to equal that. All right, so there we have it. Then, because they are on a straight line, and I have no angle Y would equal angle EFK, but there's no measurement there. But so now I have to use this property, adjacent angles on a straight line, because angle Y and that 38 degrees that I found here, angle Y and angle X do form a straight line. If you look at it, because the line would be HK, I can just simply go angle Y plus 38 degrees is 180 degrees. I subtract 38 from each side. Angle Y is 142 degrees. Okay, now let's go to a little more challenging problem. This one deals with angles meeting at a point. So we would assume it would be 360, but not always, as the case will prove to be. And try it number 4. It says, and again, look at the diagrams carefully. In the diagram, PS, QT, and RU are straight lines intersecting at V. Find the value of Z. Okay, all I have to go on is that 70 degrees. Okay, but it is vertically opposite of an angle where both of the Z's are sitting. So I am going to just say, and I'm going to skip this step this time. I'm just going to say angle UVT, again, V is the vertex, has to be in the middle, is equal to 70 degrees because it's vertically opposite angles. Now, all those angles, this angle that I just proved by the vertically opposite angle property, and the two Z's that are there, so two Z's are equal, they're all sitting on a straight line, which is PS. Okay, so angle Z plus angle UVT plus Z degrees are all 180. I found out that UVT is 70, so seriously, this part you could probably go straight to this step and prove it with this also, because you've already done this part. In my opinion, you would not need to write this, but you can go Z degrees plus 70 degrees plus Z degrees is 180 degrees. Again, you have two of the Z's, 2Z plus 70 is 180. Okay, I'm working down to Z, so I'm going to subtract 70 from each side first. I have 2Z is 110. I divide through by 2 to work down to single Z, and therefore Z equals 55 degrees. So there you have it. In today's lesson, remember to include all the properties as proofs of what you do. Make sure they are listed. It's better to write too many properties and do too many steps than not enough in this case. So I will give you your assignment in class. As always, you can watch this video as often as you need it. There's lots of definitions, lots of properties. If you took careful notes, you can just refer back. Thank you, and do good math.